Hello, friends. Welcome back to another session in which we are going to continue with coordination compounds. Now, in our previous session, we have learned all about what is a coordinate bond, what is double salt, what are coordination compounds, what is complex, what is ligand, what is the classification of ligand, what is counter ion, what is central metal atom or central metal ion. Okay, and we have seen in detail the different types of ligands, their structures, and all that in our part 1. Today we are moving on to coordination number. Now, what is the coordination number? Coordination number is the number of ligands. I guess I have told you this in the previous session, but still, now getting a little more in depth. Okay, so coordination number is the number of ligands attached to a particular central metal atom. That is called as the coordination number. Now, for example, here we are having PTCl6, so 6 becomes the coordination number. Here we are having NiNH3 4 times, so the round bracket is indicating the ligands, and there are 4 ligands, so hence the coordination number becomes 4. Okay, now if all ligands are of the same kind, we call them as homoleptic. And if there are different kinds of ligands attached, we call it as heteroleptic. Have a look at this and try understanding what is homoleptic. See, all are NH3, all 6 are NH3. Like last video, we have seen the example of K4FeCN6. So CN6 is again 6 times 6 ligands of cyanide attached to Fe. So that is again a homoleptic ligand because ligands are of the same kind. Okay, then now example of a heteroleptic ligand is over here. There are, oh, I think you're not able to see this, right? Just let me adjust the camera a little. Yeah, I think it's better now. Okay, so NH3 is 4 times and Cl is 2. Okay, so there are two different kinds of ligands. Mind you, this is not the counter ion. Is this Cl outside the square bracket? Not at all. It is inside the square bracket and it is acting as a ligand. So hence this is a heteroleptic complex. Now what do you mean by heteroleptic? There are different kinds of ligand. Then moving on, here, tell me what will be the coordination number. Here the coordination number is 2. Tell me what will be the coordination number over here. Coordination number will be 1 plus 5, that is 6. 6 is the coordination number over here and 2 is the coordination number over here. This is a homoleptic complex. This is a heteroleptic complex. Fine. Moving ahead now, an important thing, EAN. What is EAN? Effective atomic number. Now, what is effective atomic number? It's a way to calculate the, uh, you know, check. It's a way to check the stability of the complex. Now, how do we check the stability of the complex? If your effective atomic number is equivalent to a noble gas, that means your complex is stable and it's a successful coordination compound. If it is not equivalent to the atomic number of a noble gas, then it is not a stable coordination compound or it is not a stable complex. First of all, let us have a look at what? At the different noble gases. Tell me which are the different noble gases. Group 18, come on, you already know it. Let me give you a small mnemonic in case you have forgotten them. Harbhajan ne Arnold Co. Arnold was a cricketer. Harbhajan ne, of course, Harbhajan is also or was a cricketer. Harbhajan ne Arnold Co. 0 runs diye. Okay, 0 runs diye. 0 is the Xerox wala 0. Okay, so Harbhajan, okay, ne Arnold. So hydrogen reminds you of helium, Ne reminds you of neon, Arnold reminds you of argon, Co reminds you of krypton, 0 is the Xerox wala, 0 reminds you of xenon, and runs, Dia does not stand for anything, runs reminds you of radon. All these are noble gases, sir. But how do we remember the atomic numbers? Now for remembering the atomic numbers, just remember this sequence. This is applicable for the S block and group 18 as well. Okay, S block and group 18 के लिए sequence से याद रखना है. Sir, ये atomic numbers है क्या? No, these are not the atomic numbers. So what we have to do is we can remember the first element's atomic number. All of us know that helium's atomic number is 2. Okay, not more than 2, right? So 8, just add 8 to this. When I add 8 to this, this becomes 10. then add 8 again, this will become 18, add another 18, it becomes 36, add another 18, it becomes 54, add 32, it becomes 86. This is a tip, a mnemonic, a way, a trick to remember the atomic numbers, the group 18 elements along with their atomic numbers. Now once you know their atomic numbers, now it will be easier for us to find out the EAN. Say for example, let's take the famous compound which we had taken last time as an example for explaining the different ligands and everything. We had also seen the VBT, yeah, D2sp3 hybridized, that thing we had seen for this compound only. This was the example which we had taken in the previous video. So again, once again, we are taking the same example, but this time to calculate the EAN, effective atomic number. So इफेक्टिव एटॉमिक नंबर द फॉर्मूला इज z माइनस x प्लस वाई. सर ये z क्या है, x क्या है, y क्या है? सो z ये आपके सेंट्रल मेटल एटम का एटॉमिक नंबर, इट्स द एटॉमिक नंबर ऑफ द सेंट्रल मेटल एटम हु दिस Fe. इसका Fe का एटॉमिक नंबर लेना है z की जगह पे. x क्या है? x इज द अमाउंट ऑफ इलेक्ट्रॉन्स और नंबर ऑफ इलेक्ट्रॉन्स लॉस्ट बाय, yeah, number of electrons lost by central metal atom, or you can say the oxidation number of the central metal atom. Okay, central metal atom or ion, of course. Okay, central metal atom or ion, इसका हमको क्या देखना है? How many electrons is the central metal atom losing or gaining, whatever, that is going to be x. Or y क्या है? Y is going to be the number of electrons gained by the central metal atom, right? Number of electrons gained by central metal atom, I'll just call it as CMA, central metal atom. मतलब electron कौन दे रहा है? Of course ligands electron दे रहे हैं ना, ligands are giving the electrons to the central metal atom. Just let me remind you about the structure of K4FeCN6. You have Fe in the center, we had calculated last time, right? This was having D2sp3 hybridization, but इस बार हम लोग EAN calculate कर रहे हैं. इसमें we are having 6 cyanides, और मैंने आपको बताया था कि ये सारे के सारे cyanide, these are ligands. That means Fe is not giving a single electron to cyanide, but in fact cyanide is giving a lone pair of electrons to Fe and forming a coordinate bond. That's what we had discussed in the beginning of the video in part 1, right? So cyanide is giving a lone pair of electrons and forming K4FeCN6. It is a ligand, and ligand is an electron donor molecule. Electron donor molecules are also called as Lewis bases. All that we have discussed in the previous class. So K4FeCN6 cyanide electron Fe को दे रहा है. Fe के पास उतनी जगह करनी पड़ती है उसको इलेक्ट्रॉन्स लेने के लिए. तो Fe टोटल कितने इलेक्ट्रॉन्स ले रहा है? 1 2 3 4 5 6 7 8 9 10 11 12. A total of 12 electrons are being accepted by Fe. So what will be the value of Y? Number of electrons gained by Fe? It is gaining 12 electrons. From whom it is gaining? From the ligands. Ligands are donating the 12 electrons to Fe, in this case K4FeCN6. तो चलो फटाफट वैल्यू सब्स्टिट्यूट करते हैं. EAN is equal to, बोलो, EAN is equal to atomic number of Fe. What is the atomic number of Fe? 26, of course, minus X, number of electrons lost by the central metal atom, that is 2 इलेक्ट्रॉन्स आर लॉस्ट, क्योंकि ऑक्सीडेशन नंबर उसका +2 है. हम लोग ने कैलकुलेट करते हुए देखा था कि एटॉमिक नंबर इज +2. ओके सर, अगर हमको पता नहीं तो हम लोग कैसे कैलकुलेट करें? ठीक है, अगर आपको पता नहीं, अभी चलो मेरे को पता था इस केस में कि Fe का ऑक्सीडेशन नंबर +2 है, बट अगर आपको पता नहीं तो आप क्या करोगे? तो आपको कुछ थोड़ी बहुत चीजें पता होनी चाहिए, जैसे कि K is +1, लास्ट टाइम बताया था K is +1 and +1 into 4 is +4, so this will have obviously a charge of -4. तो अब आपको क्या करना है कि Fe का चार्ज फाइंड आउट करना है, तो Fe को x ले लो, राइट? और साइनाइड पे चार्ज है -1. -1 is the charge of one cyanide. There are 6 cyanides like this, so -1 into 6 equal to this charge. What is this charge? -4. Now calculate the value of x. X minus 6 equal to -4. Send 6 on the other side. +6 minus 4 is equal to +2. That's how Fe का चार्ज कितना आ रहा है? +2 आ रहा है. Okay, that's how I have taken +2 over here. And plus y is the number of electrons gained by Fe. How many electrons is Fe gaining? 12, because I told you over here in this structure that cyanide is giving a total of 2. All the 6 cyanides together are giving 2 2 2 2 2, and which totals up to 12 electrons. तो अब आप थोड़ा सा कैलकुलेट करेंगे. 26 minus 2 24 plus 12 36. तो 36 इसका EAN आ रहा है, इफेक्टिव एटॉमिक नंबर आ रहा है. एंड इफेक्टिव एटॉमिक नंबर जब 36 है तो 36 इज द इफेक्टिव एटॉमिक, आई मीन इट इज मैचिंग विद द नोबल गैस 30 क्रिप्टॉन. ओके, आपका जो EN जो कुछ भी आएगा वो इनमें से किसी भी एक को मैच होना ही चाहिए, तभी हम लोग उसको एक स्टेबल कॉम्प्लेक्स या फिर एक स्टेबल कोऑर्डिनेशन कंपाउंड कंसिडर कर पाएंगे. ओके, सो इन दिस केस फॉर दिस कंपाउंड वी हैव गॉट व्हाट? 36 as the EAN. Okay, so let's calculate this EAN for a few more compounds and see whether those compounds are stable or not. Okay, so here we are having, just let me straighten this a little. Yeah, so here we are having EAN. I've already given you the formula, Z minus X plus Y. तो कुछ कंपाउंड्स है जैसे कि ये वाला, अब आप खुद कैलकुलेट करेंगे CO, पॉज द वीडियो और खुद कैलकुलेट करो इसका EAN, CONH36Cl3, इसका EAN आपको खुद को कैलकुलेट करना है, ठीक है। अगर आप पॉज नहीं भी कर रहे तो एनीवेज वी आर गोइंग टू सॉल्व, तो इधर ही सॉल्व कर देता हूं मैं। CONH3 6 टाइम्स Cl3, तो अब CO CO का हमको क्या कैलकुलेट करना है, EAN कैलकुलेट करना है। EAN इज इक्वल टू Z माइनस एक्स प्लस वाई। अब एटॉमिक नंबर पता होना चाहिए कोबाल्ट का, अगर नहीं पता है तो फिर भी आपको मैंने एक निमोनिक दे रखा है, साइंस तेरी वावा करे मानव, फिर कौन निकालेगा कॉपर से जिंक। ओके, that means scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper and zinc, right? तो cobalt का atomic number है 27. 27 is the atomic number of cobalt. Okay, then how many electrons is it losing, that we'll have to calculate. Let us take cobalt as X. NH3 is a neutral ligand, mind you, तो उसका charge कितना है, 0. 0 into 6, this is having -1 into 3 -3, so this will have a +3 charge. This is equal to +3, so X minus 0 into 6 is 0, प्लस इज इक्वल टू +3, सो इक्वल टू +3 मतलब क्या आएगा यहाँ पे, डायरेक्टली x का चार्ज +3, सो हियर आई विल राइट -+3 plus y is the number of electrons gained, 6 ligands है, 6 is the coordination number, तो obviously 12 electrons it's going to gain, so +12, so 27 minus 3 कितना होगा सर, 27 minus 3 is 24, 24 plus 12 is 36, once again 36, that means it is equivalent to the atomic number of a noble gas and it is stable. Let's check. Yeah, check, effective atomic number is coming as 36. Come on, do the next one, K4FeCN6. K4FeCN6 already हम लोग ने कर रखा है, right? As an example we had taken and the answer had again come 36, तो इसको हम लोग skip करते हैं, we'll move on to the next one, NiCO 4 times. How will you calculate the effective atomic number for this one? Effective atomic number nickel, nickel atomic number actually पहले formula लिख लेते हैं, EAN is equal to Z minus X plus Y. Atomic number of nickel is 28, then minus x. अब निकल का चार्ज, निकल का चार्ज कैसे फाइंड आउट करेंगे, न्यूट्रल है, राइट, सो दिस इज लाइक Ni को हम लोग ले लेंगे x माइनस 0 इंटू 4 इक्वल टू 0, क्योंकि ये जो स्क्वायर ब्रैकेट है, स्क्वायर ब्रैकेट ड्रॉ नहीं किया है क्योंकि ये न्यूट्रल है, क्योंकि इसके ऊपर कोई चार्ज ही नहीं है, सो दिस इज इक्वल टू 0, तो एंटायर x इज इक्वल टू व्हाट, 0, तो x इज इक्वल टू 0, x माइनस 28 माइनस 0 प्लस 12, ओके, सॉरी 12 नहीं, कितने इलेक्ट्रॉन्स गेन कर रहा है यहाँ पे, कार्बन कितने हैं, 4 लिगैंड्स है, तो दो इलेक्ट्रॉन्स देंगे, 2 4 जा 8 इलेक्ट्रॉन्स ये एक्सेप्ट करेगा, सो 28 प्लस 8 इज वंस अगेन 36 एंड दिस इज ऑल्सो स्टेबल, राइट, 36. तो नेक्स्ट आपको करना है इफेक्टिव एटॉमिक नंबर कैलकुलेट K2PtCl6 का, बट वी नीड टू नो द एटॉमिक नंबर ऑफ platinum. Atomic number of platinum is 78. Okay, so EAN is equal to Z minus X plus Y. Z बताया गया है 78 is the atomic number of platinum. X, we have to find out the charge on PT. X is equal to, this is +1 into 2 is +2, so here we'll have -2, right? PT is X minus 6. How 6 sir? -1 is the charge on Cl into 6 equal to -2. -2 is the charge over here, ये यहाँ पे रख रहा है, so x minus 6 equal to -2, 6 will go on the other side, you will get 4, x का value 4 है, so x instead of x we'll write what, 4, -4 is the oxidation number or the number of electrons lost by PT. Okay, so that is -4, and how many electrons it is gaining, 6 Cl are there, 6 is the coordination number, that means every Cl will give 2 electrons, and the number of electrons gained by the central metal atom will be 12, so 78 minus 4 is 74, 74 plus 12 is 86, and 86 is the oxidation number for what, यहाँ पे देखा था हम लोग ने, 86 is the oxidation number for, देखो, रेडॉन, रेडॉन का ऑक्सीडेशन नंबर है 86. सो Now let's check 86 is the correct answer. Yes, it is the correct answer. फिर अब आप ये इसको सॉल्व करो. ZnNH3 4Cl2 Zn का एटॉमिक नंबर मैं आपको बता देता हूँ 30. अब तो ओवरली कर सकते हैं, राइट? तो 30 दिस इज जीरो. ओके, किसका? NH3 का चार्ज जीरो है, तो इसके ऊपर चार्ज कितना आएगा? x माइनस जीरो इक्वल टू, दिस इज -2 विल काउंटर आयन विल बिकम +2, सो इक्वल टू +2. Zn का चार्ज इज +2, सो इट इज गोइंग टू बी 30 minus 2 plus 8, because there are 4 ligands, so plus 8. So 30 minus 2, yeah, 30 minus 2, 28, 28 plus 8, 28 plus 8 is once again 36. अब तो orally कर रहे हैं, इतना practice हो गया है, right? 36 is the effective atomic number for this compound. So this is how we are calculating the effective atomic numbers. Easy है बहुत.